So it seems like a leap. We're going to talk about nails. Say you're building a fence or replacing a fence in the backyard, and you need some nails. And so you figure out, okay, this is many pickets and this many this and this. I need this many nails. And it might be like, I need 2,214 nails. So you go to the hardware store, and they've got this big bin of nails. You're going to stand there and count out 2,214 nails? No, that would take a long time. And you'd probably get distracted and lose count and have to start over again. And then you'd maybe decide to move to somewhere else that had a good fence. It's too hard. You don't count out that many nails. You can use weighing to count. Does it matter if you get exactly the right number of nails? No, because you're probably going to drop some in the dirt and not be able to find them. You're going to hit one with the hammer wrong and bend it over. And if you have 5 nails left over, is that the end of the world? No, the exact number doesn't matter. So we we count things by weighing them. And the same idea applies to atoms. The difference is atoms are too small to physically count, and it also would take too long. I forget the exact analogy, but I think if you counted the molecules in a teaspoon of water at a rate of 1 per second, and you didn't sleep and you didn't take any breaks, it would take like 1,000,000 years or something to count the molecules in a teaspoon of water. I mean, we're dealing with ginormous numbers here. There's no counting involved, and yet we need to know how many atoms there are, so we count them by weighing them. If we know how much each one weighs, then we can weigh the whole bunch of them and figure it out. It's the same thing we do with nails. So let's think about how this works. The hardware store customer buys 2.60 pounds of medium-sized nails. A dozen nails weigh 0.150 pounds. How many nails did he buy? This sounds like one of those questions they asked you in elementary school, doesn't it? This is a word problem. So let's write down the numbers. 2.60 pounds of nails. And then this, one dozen nails weighs 0.150 pounds. So 1 dozen nails is equal to 0.150 pounds. You okay with that? If you took 12 nails and you weighed them, it would be 0.150 pounds. So a dozen nails is equal to 0.150 pounds of nails. This is a conversion factor. This is my amount of nails. I want to get to number of nails. This relates a dozen nails to mass. So I can go from the mass, the amount of nails in pounds, to dozens. I can figure out how many dozen nails. And then from that, I can figure out the actual number of nails. How many nails are in a dozen? 12. How do you know that? You just know that, because that's what a dozen means. A dozen is 12 things, right? Could you have a dozen donuts? That sounds kind of good right now. Could you have a dozen moose heads staring at you? Yeah. 2, 4, 6, 8. There's over a dozen of them. They're creepy. So 1 dozen equals 12 nails. So we made a path here. And I'm going to have 2 conversion factors. So 2.60 pounds times and a fraction times and a fraction. I'm going from pounds to dozens to individual nails. Pound to dozen to individual nails. So I'm going to put dozen down here. So those cancel out. And I'm going to put pounds down here. So those cancel out. 1 dozen nails is 0.150 pound. So 1 dozen is 0.150. Only true for this question, for medium-sized nails of this type. And then 12 nails is a dozen. And so we can figure out how many nails. 2.6 divided by 0.15 times 12, 208. 208 nails. Any questions? Does that make sense? Is that a practical type of calculation? Could you imagine a scenario where you might need to do something like that? It's possible, right? You got to admit that it's possible. This dimensional analysis stuff can be useful and often is in real life.